Here we're going to take a look at a cool little theorem called the Remainder Theorem. The Remainder Theorem, it is a theorem that tells us, it gives us a interesting way to interpret the result of synthetic division. So we have this problem. It says, use the Remainder Theorem to evaluate f of x equals 3x cubed plus 8x squared plus 5x minus 7 at x equals -2. Well, first off, what do we mean when we say evaluate f of x at -2? That's saying find f of -2 at our function. So doing it the old-fashioned way, we would plug -2 in for every x. Once we plug that -2 in, we of course then just simplify and evaluate our function. So I won't go through the whole steps here, but eventually as you simplify that, you would get -9. So that's saying f of -2 is -9. And that's the old way. But now we are advanced and we're going to learn a neat way to do it differently using synthetic division. And that's where we look at the remainder theorem. So in its glory, it says, if a polynomial f of x is divided by x minus k, the remainder is r equals f of k. So if I divide some polynomial and I get a remainder, that number is the same as evaluating at that factor, at the number, that k number of the factor. So in this case, I'm at x equals -2, which means I have the factor, I would have the factor x minus a -2. Because remember, all our factors, they are of the form x minus k, so we have to have minus the x value that we're evaluating at. So in fact, I'm evaluating at x plus 2 as the factor. And we're going to use, so in order to quickly divide that polynomial, we will use synthetic division. Now we could use polynomial long division, but we've seen how synthetic division, once we get good at it, we can go through it a lot quicker. So I will use synthetic division. I'll go -2 up in my corner and then list out the coefficients. 3, 8, 5, -7, and I represent each power of the exponent, so I'm good to go. Also, just keep in mind, we can only do synthetic division when our factor is of this form, x plus 2. And also notice the remainder theorem up here only works when it's of that same form, x minus k. So x plus k or x minus k. All right, with synthetic division, drop down our first number, and then I go -2 times 3, and then add. And then keep repeating this process. -2 times 2, -4. Add, and I get 1, -2 times 1, -2, and add these, I get -9. And remember how the last term in our synthetic division is the remainder. And then according to the remainder theorem up here, this is telling me I divided by x plus 2, therefore my remainder, which is -9, is equal to f of k. So it's equal to f of -2. So by going through synthetic division and looking at the remainder, I found a new way to evaluate my function. And in fact, as we get good with synthetic division, that is a much quicker route, especially when you get these higher powers, these longer polynomials. It takes a while to get through all of that using the calculator or just your mental prowess. It takes a while, but with synthetic division, you can run through that really quick. Let's try another example. Use the synthetic division to find f of -1 if f of x equals 2x to the 4th minus 3x squared plus 5. So if I'm trying to find f of -1, I can think of that, so that means I'm dividing by the factor x plus 1. But whatever number you're evaluating at, that's your little number up in the corner. And then I'll list out my coefficients. This time I have to pay attention. The x cubed power, that was passed over. So I have to put in a 0 and then -3. Also, the x to the first power was passed over, so I have to put a 0 for that. My coefficients are listed out, so we can go through this process. Drop down the 2, multiply by -1, add 0 plus -2 is -2. -1 times -2 is a +2. -3 plus 2 is -1. Multiply these together, get a +1. 0 plus 1 is 1. And finally, -1 times 1, -1, add, and 4. 4 is our remainder when we divide by x plus 1, which also means f of -1 is equal to 4. And that was a pretty quick process. Well, we were going at -1, so maybe we could have quickly done it in there, substituting in -1. But you will find there are times where this is a quicker process. And even without that, it's just a neat result where we wouldn't necessarily think that synthetic division is related to evaluating a function. But we have that remainder theorem to make that link. You will sometimes actually see this process we just completed called synthetic substitution. So synthetic substitution and synthetic division are the exact same process. It's just how we interpret the end result is a little bit different.